Hello to everyone. This is Shantan Kumar, Department of Mathematics, Institute of Aeronautical Engineering College, Dundigal, Hyderabad. Today we are going to discuss the topic subject is differential equation in vector calculus. Today we are going to discuss the topic on the module 1, the question bank part A. First of all, before going to discuss the part A, that is a model 1 question bank, that is the differential equation of the first order and first degree. First, we discuss that what is the syllabus and what are the topics which is covered and what are the formulas based upon this module 1 we need to discuss here properly. The syllabus under the module 1, it is the exact differential equations, equations are reducible to exact differential equations, linear and Bernoulli equations, applications under here, the orthogonal trajectories, under here Cartesian coordinates only, and based upon the Newton's law of cooling. Here, the topics clearly, first we will go to discuss here one by one regarding the module 1, that is the introduction, the differential equations. Second, that is exact differential equations, non-exact differential equations, linear differential equations, and Bernoulli differential equations, and applications under here, the orthogonal trajectories, which we are going to discuss only the Cartesian coordinates, and finally, the applications, the Newton's law of cooling. Here, first, what is the definition of the differential equation? It is nothing but, a differential equation is nothing but an equation which involves a differential coefficients is called the differential equations. For example, it is d square y by dx square plus x square into dy by dx plus y is equal to 0. It is clearly the differential equations. Under here, the differential equation, we are going to discuss like dividing the two types. One is the ordinary differential equations, second one is the partial differential equations. For example, the ordinary differential equations. And here, what is the meaning of ordinary differential equations? And again, second one, what is the partial differential equations? How to define the, these are the different two types of the differential equations. Before going to discuss that, again, the dy by dx. That means here based upon that, the numerator, it is a dy by dx. It is dy, that is numerator. It is called as a dependent variable, and whereas the denominator, which is called as a independent variable. And here, y is a dependent upon x, and y is a function of x. And here, an equation which involves the differential coefficients is called a differential equations. The ordinary differential equation. Based upon the differential equations, in the previous slide we discussed like the two types. One is a differential equation, that is the ordinary. Second one is a partial differential equations. First we are going to discuss what is the meaning of ordinary differential equations. And this is nothing but based upon the dependent and independent. Here, whereas the ordinary differential equation is nothing but it is one or more variables, and here only one independent variable, then it is called as a ordinary differential equations. And coming to partial differential equations, and this is a clear example for the ordinary differential equation. That is nothing but one dependent, one independent variable occur only. And whereas the partial differential equation. And coming to the partial differential equation is nothing but it is at least two independent variables. That is the meaning of the partial differential equations. That is two or more independent variable. That is the meaning of at least two independent variable occurring. The type of the differential equation is called, that is a partial differential equation. For example, here dou y by dx plus dou y by dou t is equal to 0. Where we are going to observing here, it is a ordinary differential equation, one dependent, one independent. And here the partial differential equation is nothing but one, it is a more than the two independent, that is at least two independent variable. And here, as per the syllabus, we are going to discuss what is the exact differential equations. The exact differential equation is nothing but the definition, a differential equation of the form m is a function of x comma y into dx plus n is a function of x comma y into dy is equal to 0. That means m comma n is a function of x comma y. M is a coefficient is dx plus n is a coefficient is dy is equal to 0, where m and n are the functions of x and y is said to be exact differential equation. And if dou m by dou y is equal to dou n by dou x is it holds. That is the meaning of the exact differential equation. Here, the necessary and sufficient condition for the exact differential equation is that is dou m by dou y is equal to dou n by dou x. That means whenever we need to say that the given differential equation is an exact differential equation, here the condition is satisfied that dou m by dou y is equal to dou n by dou x, where m comma n is a function of x comma y. The condition is exist, dou m by dou y is equal to dou n by dou x. And if it is satisfied the exact differential equation, here the general solution of the exact differential equation is nothing but it is integration m dx. Wherever the m is a function, it treated as a y is a constant. That means on the given function m, we need to integrating with respect to dx, treat y is a constant. The terms of n which is free from x into dy is equal to c. That is the meaning of from the rest of the nth term, which is we need to consider that is n is a free from x into with respect to dy is equal to c. This is the clear concept of the exact differential equation. That means whenever the equation is in the form of dou m dx plus n dy is equal to 0, if it is dou m by dou y is equal to dou n by x is existed, the function is said to be exact differential equations. And here the general solution is nothing but integration m treated y is a constant into dx plus terms of n free from x into dy with respect to is equal to c. This is the exact differential equation. We need to remember here the dou m by dou y is equal to n by x, and second one that is a formula that is integration m dx y constant plus terms of n free from x with respect to dy is equal to c. Next, coming to based upon the exact differential equation, what is the procedure? Where is the previous slide that is a condition to exact and solution. But here, what is the procedure for the exact differential equations? And based upon the previous slide, here we need to assume that equation of the form that is m dx, that is m is a function of x plus n dy, n is a function of x comma y into dy is equal to 0. Here, comparison with the help of this is the equation. And step 1, we need to find out what is the m comma n by comparison the given differential equations. Step 2, we need to find out what is the dou m by dou y and dou n by dou x as a partially. That means m with respect to y and n with respect to x as a partial. And here the condition it is exist, that is the meaning of dou m by dou y is equal to dou n by dou x with the help of the dou m by dou y and dou n by dou x. Then if it is satisfied, the equation is said to be exact. And next fourth one, according to the general solution we need to calculate, that is the integration m dx, that y is treated as a constant plus terms of n free from x into with respect to dy is equal to c is the condition. This is the working rule for the procedure for the exact differential equations. For example, we need to check before going to calculation the formula like the problems, we need to understand the basic concept here how to what is the meaning of it is a free from x from the given function n, which is containing m, which is not containing the n. For example, it is m is a function. For example, if it is assumed m is a function, and again here n is a function. While we are going to take that here, it is a from that n we need to discuss here n free from x. Somebody are unable to understand what is the meaning of n free from x. That is n should not containing x. Here, while we are going to observing here, it is in this, for example, it is nth term, it is containing x. That means we should not replace in the n free from x. It is the n containing x. Therefore, we need to avoid this the nth term. And again, the second term, it is not containing x, it is existed. Therefore, in this formula, we need to replace that is the integration y cube into dy. That m is as we need, according to we need to find out with respect to x only. Treated y is a constant. For example, other example that is m is a function like this and n is a function is like this. And based upon this one, at the time of this finding the calculation, it is the n free from x. Here also, based upon this observation in this n, free from x is nothing but first term it is a containing x, therefore we need to avoid. The second term is also we need to avoid because n is a containing x, and we need to consider only minus sin y into dy. This is the meaning of n free from x. For example, we need to assume that one other example, m is a function and also n is a function. And again here also, for example, while we are going to integrating, here n free from x is nothing but here this is the first term and second term and third term. Unfortunately here the first term is containing x, therefore it is avoid, and second term is also containing avoid, the third term is also containing x, that is also avoid. This is the observation when we are going to calculating that exact differential equation in the second term, that is n free from x into dy is equal to c. And again one other example, similarly m is a function and n is also a function, and here also n is a function, it is only one function, that is a one term, that is minus 2xy, and which is also containing x, therefore we need to avoid this is the term. Therefore in this there is no nth term, n term free from x, therefore you need to avoid. And similarly we need to assume that other some example based upon this easy to calculating at the time of the given problem. And m is a function, for example n is a function, and again n, that means here totally this is the function is multiplication with the x, that is n free from x is nothing but which is totally we need to avoid this is the terminology, that is n should not containing any free from x. Therefore similarly that m is a function and n is a function, and we need to observe properly here in that n is also free from x is nothing but when we are going to divide the two terms, that is y by something x square plus y square minus 2x by x square plus y square. Entirely this is also one term or two terms, whatever it may be. It is also denominator which is containing x. It is not possible to separate that individually. Therefore, it is also totally we need to avoid this the terminology. Therefore, n free from x here also the term is a 0. And other one like m is a function and n is a function. And based upon this one, here x cube by y power 4 plus y cube by y power 4. Based upon this one, after splitting like the two terms, it is a one term is x cube by y power 4 and other term is 1 by y. Here we need to assume that free from x is nothing but it is a first term, it is a avoid that because of it is a not free from x, it is a second term which is only consideration, that is 1 by y, that we need to replace in the nth terminology in the second term. Therefore this is the basic concept we need to understand while we are going to discuss like that exact differential equation problem. It is very helpful for anyone. Next one, what is a non-exact differential equation? The non-exact differential equation is nothing but where we discussed in the previous slide, that is exact is nothing but the condition is dou m by dou y is equal to dou n by dou x, but non-exact differential equation is nothing but whenever the given differential equation is a not exact differential equation, the condition is said to be that is a non-exact differential equation. That is the meaning of the condition is dou m by dou y is not equal to that is a dou n by dou x. Where it is a dou m by dou y is equal to dou n by dou x is condition is said to be exact differential equation, but here dou m by dou y is not equal to dou n by dou x, the condition is said to be that is a non-exact differential equation. And if it is a non-exact differential equation, according to working rule, we need to reducible to exact differential equation and after that proceeding the previous, that is the working rule of the exact differential equations. Yeah. Next one, if it is a not exact, like if it is not exact, then how to reduce it to exact? And meanwhile, we are going to multiplication with by using the integrating factor. We need to understand what is the meaning of the definition of the integrating factor, why we are going to using this the integrating factor. The integrating factor is nothing but which we are going to using whenever the equation is not exact, while we are going to change into like the exact differential equation, we are going to multiplication with any suitable factor. Either the factor is x comma either x variable or y variable or any constant values, that by using that values we need to multiply the given equation, then the equation is reducible to exact differential equation. That is the purpose of we are going to using the integrating factor. Here, if a differential equation of the form that is mdx plus ndy is equal to 0 is not exact, then according to here we are going to using that it is then it can be made exact by multiplication by a suitable factor, that is either the function of x or something y, or sometimes it is a constant values are also, it may be comes to exact differential equation. Here whatever the multiplication with the suitable factor, that factor is called as a integrating factor. And based upon the integrating factor, we are going to some of the methods are there. And before going to that also, we need to understand the meaning of that is a homogeneous, what is a non-homogeneous equation. The homogeneous equation. The homogeneous equation is nothing but in generally the terminology homo means that is the same. The like in general terminology it is the same. And here also the homogeneous equation is nothing but according to the differential equation terminology. Whenever the numerator term or denominator the degree the powers of the variable that is the order is the same, the function is said to be homogeneous. That means a differential equation is called the homogeneous differential equation if each term has the same degree. And we are, if it is not understanding based upon this statement, just we need to observe one of the example. It is xy minus 2y square into dx plus minus of x square minus 2x 3xy into dy is equal to 0. While we are going to observe here, the x power is 1 and y power is also 1. The middle of the term is a product. Therefore, 1 plus 1 is nothing but it is a 2. That means the terminology of that x comma x into y is the degree is a 2 and y is also degree is also 2. That means here the first term total it is a degree is 2 and again the second term it is also the degree is a 2 and here also 1 and 1 the middle of the term is a positive product. Therefore, 1 plus 1 is also nothing but 2. Therefore, in this totally the first dx coefficient is a power order is a like 2 and again the dy coefficient is also the order is a 2. That means the same degree which is happening here. Therefore, the function, the differential equation is said to be homogeneous function and based upon that homogeneous differential equations. Here, each term of the degree is the 2 is the condition. Therefore, the differential equation is a homogeneous differential equation of the first order and first degree. And second one, the non-homogeneous differential equation. Where we are observing the previous one that is the same degree is called as a homogeneous. If it is the same degree is not equal in the dx coefficient and dy coefficient, such type of the differential equation is said to be non-homogeneous differential equation. Here, when a differential equation is not homogeneous, it is called as a simple terminology, it is a non-homogeneous differential equation. And here also, for example, it is a consideration x square y minus 2y square into dx minus of x square minus 3xy square into dy is equal to 0. While we are going to observing here, it is a second and it is 1, but it is a product is there. The 2 plus 1, it is the order of the given function that is xy is that is a 3, but whereas it is a order is a 2. Therefore, in this first case itself, it is a non-homogeneous differential equations. Here, each term of the does not have the same degree. It is called as a non-homogeneous differential equations. Therefore, the equation is said to be non-homogeneous. And based upon this, the like such type of this, the integrating factor and homogeneous and non-homogeneous equation, we are going to like some of the methods are that is the integrating factor when the equation is not exact, how to reduce it to exact. Meanwhile, we need to understand some of the methods to exact equation. Here, totally the 5 methods are there. One of the method is, for example, the integrating factor found by inspection. That is nothing but it is also called as a grouping method. And second method, it is nothing but it is a homogeneous equation. And the third method, y into f of x comma y into dx plus x into the a of x comma y into dy is equal to 0. The fourth condition, whenever the equation is not suitable for that any 3 conditions, the equation is nothing but m dx plus n dy is equal to 0. And fourth one, fifth one is also m dx plus n dy is equal to 0. When we are going to using these are the methods, that is nothing but whenever the equation is not exact, we are going to change it to exact differential equation. We need to remember these are the 5 methods for the reducing to exact differential equation and solving the exact differential equation. Here, as you know that first method integrating factor found by inspection, or sometimes it is called as a grouping method. That means whenever the equation is not exact, we need to observe that first of all, is it suitable for that any like formula is satisfied or not without calculating any modifications, or by using the modification is also is it suitable for that any grouping method by applying the directly integration part. If is it satisfied, we need to follow that. Second one, the homogeneous. If it is not suitable for the found by inspection or not grouping method, we need to check that is it satisfied the homogeneous or not. That means these are also all the 5 methods are applicable whenever the equation is not exact. One is the grouping method and second one is homogeneous. That means in the previous slide that is also clearly explained, is it homogeneous or not, then how to identify the homogeneous, then how to find that. Here, if it is a homogeneous equation is satisfied whenever it is a not exact differential equation, then we need to find out that is integrating factor is mx plus ny is not equal to 0. The integrating factor is we need to assume that 1 by mx plus ny is a condition. For example, it is not suitable for the method 1 and method 2. Then what we need to do that? Then immediately we need to check that whether the function is y into function of x comma y into dx plus x into g of x comma y into dy is equal to 0. Then we need to find out is it mx minus ny is not equal to 0 or not. If it is mx minus ny is not equal to 0, then integrating factor is 1 by mx minus ny is a condition. And in this case also it is not suitable. That means it is not exact, it is not grouping method, not a homogeneous, not a y into something function. Then alternate what are the method to find the solutions. And immediately you need to check that we need to follow that understanding that is a fourth case and also fifth case. Whenever the function is mdx plus ndy is equal to 0, it is equal to, if it is satisfied the suitable for that, that is a 1 by n into dou m by dou y minus dou n by dou x. And you see clearly, if it is able to get in terms of f is a function, then we need to assume that integrating factor is e power of integration f of x into dx. And in this case, it is also not suitable. We need to calculate, that is method 5, based upon the same, almost it is related like this, but we need to observe that properly. It is in place of this one, 1 by m into, that is dou n by dou x minus dou m by dou y is equal to, the output is which is a function involving in terms of y only. Then integrating factor is e power of integration z of y into dy. These are the sum of the methods. Whenever the given differential equation is not exact, we need to follow these are the one by one conditions. And especially while we are going to observing that fourth one and fifth one, it is not able to directly identification because of the first method easy to understand, the second method is also easy to observe that, and third method is also easy to suitable, but fourth and fifth it is not able to understand properly. But sometimes we need to logically we need to identify it is, if it is happening the dx coefficient, it is a like any small quantity to division is possible, then you need to assume that 1 by m. And again sometimes it is a possibility is n is a small quantity in the given differential equation, then you need to consider 1 by n is the function. And based upon that observation, this one, it is suitable for the fourth method, then the output is a function of x is properly in alone only, then integrating factor is we need to assume that. In one case, that is a other condition, it is a 1 by n, it is a suitable for that 1 by m, it is alone the function is in price of, that is g is a function of y alone, then the integrating factor is e power of integration g of y into dy. These are the 5 methods we need to remember. Whenever the equation is not exact, we need to find out by using these are the 5 methods, it is which one is suitable for the integrating factor. And after getting the integrating factor, by the definition of integrating factor, the integrating whatever we are getting here, that any one of the integrating factor which we need to multiply to the given differential equation, the equation is reducible to, that is exact differential equation. And after that, as usual, we need to find out it is integration m dx plus terms of n free from x into dy is equal to c is the condition. And next one, for example, under this is the method 1, that is a grouping method, that is a found by inspection. These are the some of the formulas we need to remember while we are going to calculation regarding the method 1. The integrating factor found by inspection, it is the first one is like around these are the like 12, and generally these are the 12 the basic formulas we need to remember. And sometimes depend upon the problems we are facing that different type of the related the different type of the formulas. For example, as we know that x dy plus y dx, that means it is we need to identify, that is the meaning of found by inspection, it is a grouping method. That means we need to remember these are the formulas, it is suitable while we are going to calculating x dy plus y dx. That is nothing but it is called as a derivative of xy, and second one the derivative of x square plus y square by 2, the third one the derivative of, that is x by y, and fourth one the derivative of y by x. That means the derivative of y by x is nothing but like this, the derivative of x by is equal to, and derivative of this one, and derivative of x by is nothing but x dy. That is a reverse order of that is a derivative process. And x dy minus y dx by y square is nothing but, that is a minus of the derivative of x by y. And sixth one the derivative of tan inverse of y by x. And the seventh one the derivative of that is log of xy, and again the derivative of 1 by 2 into log of x square plus y square, and here the derivative of e power x by y. According to when we are going to calculate in the reverse, that is a denominator into numerator derivative minus numerator into denominator derivative by denominator whole square. That is nothing but the derivative of e power x by y is satisfied y into e power of x into dx minus e power x into dy by y square. And 10th one, the derivative of log of y by x and derivative of this one, and finally it is the derivative of log of x plus y. These are the formulas, some roughly I am given here. Based upon this one, it is useful for at the time of the given differential equation is not exact, and maybe it is any one of the formula, it may be helpful. And again, sometimes other than these formulas are also it is useful. We need to observe like these are the found by inspection, or it is called as a grouping method. And second one, what is the method 2? That is integrating factor. In generally in the previous before the slide I am given that homogeneous differential equation, as we know that according to the same degree, that is a dx coefficient degree, that is order, and dy coefficient order is both are the same. The type of the differential equation is called as homogeneous. Here according to if mdx plus ndy is equal to 0 is homogeneous differential equation, and the integrating factor is here we need to assume that mx plus ny is not equal to 0, 1 by mx plus ny. And here the third type, the integrating factor, if mdx plus ndy is equal to 0 is of the form, that means here easy to identify whenever the dx coefficient is a function which is multiplication with already y, and again dy coefficient is g of x comma y, that already multiplication with x. Then immediately we need to observe that clearly it is a mx minus ny is not equal to 0. Therefore, the integrating factor is 1 by mx minus ny. And fourth one and fifth one, now only we discuss that is if it is mdx plus ndy is equal to 0, it is if it is a m or n is a small quantity, we need to assume that according to it is n is a small quantity, then 1 by n into something like that, and output is f is a function ln, then integrating factor is e power of f of x. And again similarly, if it is mdx plus ndy, and here also same like that, if it is m is any small quantity in the given equation, that is roughly we need to identify that is 1 by m into dou n by x minus dou m by dou y is equal to g of I. Then integrating factor is here integrate e power of integration z of I into dy. It is not we can say that exactly it is 1 by m and 1 by n. It may be happening, or chances are there to like 1 by m and 1 by n. That is roughly tentatively. We need to check that properly. And these are the 5 methods to whenever the equation is not exact, we need to use with the help of these are the integrating factor. And next one, like Leibniz linear differential equation. What is the Leibniz linear differential equation? Under the Leibniz linear differential equation, it is nothing but whenever already in basically in intermediate level we studied that here what are the type 1, what is the type 2. Here according to the type form 1 or form 2, and sometimes it is called as a type 1 and also it is a type 2. And what is the meaning of type 1? And type 1 is nothing but it is a dy by dx plus py is equal to q. This is called as a Leibniz linear differential equation, and sometimes it is generally it is a linear differential equation. And what is the other form? Same like that here dx by dy plus px is equal to q. While we are going to observing the type 1 and type 2, one is in terms of x and in terms of y. That is a numerator it is a y dy by dx, and again here numerator is a dx by dy. It is the meaning of the differential equation type 1 and also type 2. And at the time of the type 1, the integrating factor, that means if integrating factor is e power of integration p dx, that means with respect to dx only. And in the type 2, if it is suitable for the type 2, the integrating factor is e power of integration p dy. That is a p dy. That is a p of p is a function of y into dy. And what is the solution for the type 1? That is nothing but, as we know that y into integrating factor is equal to integration of q into integrating factor into dx plus c. This is the type 1 formula for the general solution. And what is the general solution for the type 2? Same like here also, in presence of y is equal to it is occurring x. That means interchanging y to x and x to y. And whereas in the type 2, that is x into integrating factor is equal to integration of q of y into integrating factor into dy plus c. That is a reverse, like in presence of y to x and x to y. That is a type 1 and also type 2. And here, what is the Leibniz that working rule? For example, the equation is dy by dx plus py is equal to q. This is the according to the type 1. And whatever we are following the type 1, the type 2 is also same, but only I am replacing like that y to x. First, what is the procedure for this type 1? If it is a standard equation, we need to observe that dy by dx plus py is equal to q. Then we need to find out what is step 1, what is the value of p and q. From the given equations, we need to observe properly. After that, resolving into dy by dx plus py is equal to q, what is the p and what is the q. And immediately, we need to find out what is the integrating factor. As we know that integrating factor is e power of integration p of x into dx. And third step, what is the general solution? Here, y into integrating factor is equal to integration of q into integrating factor into dx. And same like this, the type 2 is also in place of you need to find out according to that step 1, step 2, step 3. But in place of x is equal to in place of y, we need to replace here. It is the same type 2. And next one, what is the Bernoulli equations? What is the difference between the linear and Bernoulli? Here, whatever we discussed in the previous one, that is a linear, that is a type 1 and type 2. In the Bernoulli is also type 1 and type 2. Same like that, linear. But in addition of here Bernoulli, it is an equation of the form dy by dx plus py is equal to q into y power n. That means in previous linear equation from here to here only, but here the Bernoulli is nothing but q is a function which is additionally multiplication with y power of n. And here other type, that is the same, the reverse y to x and x to y, and it is right side is x power n. This is the main difference between the like linear and Bernoulli. Linear is nothing but dy by dx plus py is equal to q, and Bernoulli is dy by dx plus py is equal to q into addition multiplication with y power n. That is the meaning of it is a Bernoulli equations. It is called as a Bernoulli equations, where n is a real number, n is not equal to 0, 1. Therefore, this is the called as nothing but linear equation and Bernoulli. Same like that, exact, it is not exact, we need to change it to exact. And here also, if it is not linear, that is called as a Bernoulli, we need to convert it to linear and find the solutions. Yeah, what is the process to reduce the Bernoulli equations? And first of all, the equation we need a comparison dy by dx plus py is equal to q into y power n. And here directly we cannot find that integrating factor. After change it to linear, we need to find out what is the integrating factor, and in between what we need to do that. That means whatever the addition multiplication with the y power n, we need to immediately divide on both sides, that is y power n, and again after dividing like that y power n, which is reduced to according to the type of the equation. And here after getting this is the dividing like that y power n, whatever the multiplication, and here the middle of the term whatever it is there, y power of 1 minus n, which we need to assume that it is a v, or sometimes it is z, or sometimes it is p. That is depend upon the other. Sometimes we need to assume that sometimes z or sometimes v, sometimes any other terminology. And based upon that assume, we need to convert it to like that, find what is the derivative of this one, and we need to replace in the second equation, and after changing to converting it to linear, then find the integrating factor and find the general solution. This is the clear procedure to find that modification whenever the equation is not linear. If it is a linear Bernoulli satisfied, we need to divide according to that y power n is a must and should, whatever we need to assume that. And after that we need to follow that, and which is a clearly reduced linear, and further we need to find out what is a procedure to find the linear differential equations. And what are the applications? Under the applications of the first order and first degree differential equations, the basically here three different types. One is the orthogonal trajectory, second one is Newton's law of cooling, and third one is growth and decay. But as per our syllabus, we need to discuss only the first one and second one only. The third one it is not required. We are not going to discuss that is a growth and decay. Only it is regarding the orthogonal trajectory and Newton's law of cooling. And in particularly orthogonal trajectories also like two methods are occur, that is under the Cartesian and polar. But our syllabus we are going to discuss only the Cartesian coordinates, that is x comma y only. But Newton's law of cooling we are going to discuss properly. Yeah. First of all, what is the orthogonal trajectory? Then how to define the orthogonal trajectory? Where it is obtained the orthogonal trajectory? If you understand this is the meaning of the orthogonal trajectory, the origin or something, the meaning, terminology, we need to do that problems easily. That means orthogonal. As we know, the orthogonal is nothing but it is a like it is obtained from the Greek word and meaning of the right angle triangle. That is right angle only. The trajectory. The trajectory is nothing but it is a intersecting. That is a touching. That is the meaning of the Latin word. It is a cut across. That is intersecting. And based upon this orthogonal trajectory, that means orthogonal perpendicular or it is right angle. The trajectory, it is a cutting. That means if it is considered the two curves are cutting, that is nothing but intersecting in right angle, that is nothing but perpendicularly, it is called as a orthogonal trajectory. That is the meaning of the orthogonal trajectory means that is cutting somewhere across in the right angle, it is called as a orthogonal trajectory. That we need to basically understand. And here, orthogonal trajectory, clear concept, the trajectory and orthogonal trajectory. And under here, what is a self-orthogonal? A curve which cuts every member of a given family of curves according to some definite rule is called as a trajectory. And that is nothing but it is a touching or curve cutting, it is called as a trajectory. And orthogonal, that is based upon the touching, that is a perpendicular, it is together, it is called as a orthogonal trajectory. A curve which cuts every member of a given family at right angle is called as a orthogonal. And in generally, we know that if the two curves are intersecting, like that means m1 m2 is equal to minus 1. And here m1 is nothing but that is a tangent, and m2 is nothing but other curve tangent. The tangent is nothing but that is slope, that is nothing but dy by dx. That means from first m1 is nothing but dy by dx, and second m1 is nothing but dy by dx. And if it is remember that orthogonal touching, that is m1 m2 is equal to minus 1, that is nothing but here it is a dy by dx into dy by dx is equal to minus 1, and here the dy by dx is equal to minus 1 by dy by dx, and this is the meaning of it is minus dx by dy. Based upon this simple logic, remember, then easy to do the problem. That means whenever the two curves are intersecting perpendicularly, we need to assume that m1 m2 is equal to minus 1, that is nothing but dy by dx into dy by dx equal to minus 1. Automatically 1 dy by dx is equal to minus 1 by dy by dx. It is nothing but minus dx by dy. If you remember that, we can do that problems easily. And that is the meaning of this one. And self-orthogonal. What is the meaning of self-orthogonal? Whatever the orthogonal, we are not going to using the solve the equations by replacement of the given like dy by dx equal to minus dx by dy. That is after that formation of differential equation, we need to replace the dy by dx. We get the same the given differential equation. That is the meaning of together self loop or self confident level. That is the meaning of self orthogonal. A family of curves is said to be orthogonal whenever the differential equation of the family of orthogonal trajectory is same as that of the original family. That is the meaning of simple understanding. The self orthogonal is nothing but after formation of differential equation, when we are going to replace dy by dx is equal to minus dx by dy, we get the same differential equation. That is the meaning of the self-orthogonal. See, what is that? How to find the orthogonal trajectory? There are two ways. One can be Cartesian and polar coordinates. And Cartesian is nothing but x comma y function. And polar is nothing but f is a function of r comma theta. That means which is occurring in terms of r comma theta. But in our syllabus, there is no polar coordinates, only we discuss based upon the Cartesian coordinates. Here, what is the working rule under this is the orthogonal trajectory under the Cartesian coordinates. For example, the given differential given function is a function which is involving x comma y with constant c is equal to 0. As per the working rule, we need to eliminate the arbitrary constants. That is the meaning of formation of differential equations. That is nothing but the differential equation is considered with respect to x because of, as we know that the basic conditions, how to eliminate the arbitrary constants, that is nothing but if the equation is having one arbitrary constants, by elimination of one arbitrary constants, we get the first order differential equation. That is the meaning of if it is a equation is involving one arbitrary constants, the elimination of one arbitrary constants, we obtain that only first order differential equation. For example, if the equation is two arbitrary constants, by the elimination of two arbitrary constants, we obtain the second order differential equation. That is in general terminology. But here, as per syllabus, here we are going to discuss the formation of differential equation first order only required. That means the equation is occurring only one arbitrary constants. That means we eliminate the arbitrary constants by using the derivative one time. And after eliminating that, we obtain that what is it in terms of the dy by dx. Therefore, after getting the dy by dx, we need to replace orthogonal trajectory. That is nothing but, as we know that is m1 m2 is equal to minus 1. That means we need to replace dy by dx is equal to minus dx by dy. That means what is the conclusion of here? Whenever we are going to do that orthogonal trajectory, we need to formation of differential equation is first. That means eliminating the arbitrary constants. After eliminating the arbitrary constants, we need to replace the dy by dx is equal to minus dx by dy. Then after, you need to solve the differential equations. That is the meaning of the orthogonal trajectory. That is solve the differential equation to get the required equation of the orthogonal trajectory. And next one, the applications under the last one, under this is the model 1, that is a Newton's law of cooling. And here it is also already in basic level we studied, but once again here we need to discuss what is the Newton's law of cooling. Here the statement of the Newton's law of cooling is nothing but the rate of change of the temperature of a body is proportional to the difference of the temperature of the body and that of the surrounding medium. And here let us consider the theta is equal to temperature of the body at time and theta naught is the temperature of the surrounding medium. Then according to based upon the statement, the d theta by dt is proportional to theta minus theta naught, which implies that d theta by dt is equal to minus k of that is theta minus theta naught. This is the statement of the Newton's law of cooling, and based upon that we need to discuss the problem. And once again you need to observe properly how to remember these the conditions, the Newton's law of cooling. Here the rate of change of the temperature, that is denoted d theta by dt, and is proportional to, that means it is proportional. And next one, the difference, that is nothing but minus, that is the difference. And what it is here, the temperature of the body, the temperature of the body is nothing but, that is assume that theta, and that means within the bracket, and that of the surrounding medium of the body, that is nothing but surrounding medium is nothing but theta. There is a clear information regarding that, how to remember the statement based upon the Newton's law of cooling, then how to do the problems. We need to remember according to these are the logical terminology. That is theta by dt is equal to minus k into theta minus theta. And these are the some basic formulas if we remember under this is the like model 1, then easy to survive when the problems are given and how to do the problems. But finally we need to remember all these formulas must and should, then only it is solving easily. Here now our target is to model 1, the part A, that is a critical and thinking the problems under the first order first degree ordinary differential equations. First one, x square y into dx minus of x cube plus y cube into dy is equal to 0. And here this is the, while we are going to observe what we need to understand, it is the equation is in the form of, based upon the review of the previous formulas, it is m dx plus m dy is equal to 0. Therefore we need to find assume that what is m, it is m is nothing but comparison that according to the working rule m is x square y, and what is n, and n is nothing but minus of x cube plus y cube. And based upon that understanding this m and n, our concept is to find out that is dou m by dou y and dou n by dou x. Therefore dou m by dou y is equal to, and dou n by dou x is equal to 1 dou m by dou y is equal to x square, and dou n by dou x is equal to minus 3x square. While we are going to observing here, it is clearly it is a not exact. Therefore if it is not exact means we need to converting it to exact. But if it is exact, we need to find the directly solution. But it is not exact, we need to make into exact differential equations. By using that integrating factors. Which integrating factor we need to observe that properly. Therefore, here while we are going to observe here, the equation is clearly first condition it is not exist because of it is not found by inspection, it is not grouping method is not possible. Therefore, our mind will be thinking second method is we need to observe that the function is a homogeneous equation because of m comma n are both are the same degree because of the order is a 3 only. Therefore, based upon this one, the integrating factor is mx plus ny we need to find out. Here mx plus ny is nothing but whatever the m we need to multiplication, n is multiplication with y, that is mx plus ny is equal to minus y power 4, and it is not equal to 0 as per the working rule. If it is not equal to 0 means the integrating factor is that is a 1 by mx plus ny, therefore 1 by minus y power 4. As per the integrating factor, the meaning is whatever we are getting the integrating factor, this can be multiplied the given differential equations. Then the equation is reducible to exact differential equation. Therefore, by multiplication 1 by minus y power 4, it may be reducible to exact differential equation. Therefore, the equation is this one. The multiplication with 1 by y power 4. After this is the multiplication is over. This equation can be, it is considered, it is exact differential equations. And after the exact differential equation, directly we can find the solutions as I am given that integrating m dx y treated as a constant plus terms of n free from x into dy is equal to 0. And here we need to check what is that here. M is nothing but, as we know that m is this one. After that multiplication with the integrating factor, and it is n is multiplication this one, and m dx, that m we need to replace in the function as we know that right side, and n is free from x. N free from x means the first term it is a containing x, therefore which we need to avoid that one, and second one only we need to assume that is because of free from x it is satisfied, therefore it is a y is a 1 by y only. That 1 by y we can replace in this here into dy is equal to, that is a c is a condition. Now here we need to take y is a constant, that is minus 1 by y cube is a constant, integrating y constant, that is x square into dx, and 1 by y into dy. And as we know that minus 1 by y cube into integration x square with respect to x is nothing but x cube by 3 plus 1 by y integrating with respect to y is a log y. Therefore, the solution it will be minus x cube by 3y cube plus log y is equal to c is the final required solutions. Second one, 2xy into dy minus of x square minus y square plus 1 into dx is equal to 0. And here also we need to observe that properly. The equation is m dx plus n dy is equal to 0. And here also the problem is m is equal to 2xy and n is equal to minus of x square minus y square, that is minus into minus is nothing but m is equal to 2xy is clear, and n is equal to minus x square plus y square minus 1 is equal to that one. And again here m is equal to dx means it is m is nothing but minus of x square plus y square, and n is nothing but dx dy is equal to n is equal to 2xy is a condition clear. And we need to find a dou m by dou y is dou m by dou y is equal to 2y and dou n by dou x is equal to 2y. Right. Of course, it is both are the same. That means the given differential equation is a exact differential equation. And if it is exact, no need to find the integrating factor. Directly we can find the solution of the exact differential equations. As we know that the given differential equation is exact means integration m dx plus terms of n free from x into dy. And here m is equal to clearly given the right side, that is m is equal to 2xy, we need to replace terms of n free from x. And in this condition, terms of n is free from x is nothing but here m is directly we can replace minus x square plus y square minus 1, that n free from x. Free from x means here n is the term is containing totally x, therefore which we need to avoid that term, therefore n free from x is nothing but that is 0 into dy is equal to c. Directly it is a m dx means here we need to observe y is a constant. The first terminology minus common x square integration minus x cube by 3 plus y square constant means take out common. The rest of the term it is a 1. Therefore 1 into dx is nothing but that is a x minus 1 into dx is nothing but minus x is equal to c. Therefore this is the final solutions. And next one, solve that 1 plus x square into dy by dx plus 2xy is equal to 4x square. While we are going to observing this problem, it is clearly that is a linear equations maybe, that is after modification like that dy by dx plus py is equal to q. That means we need to divide that 1 by 1 plus x square on both sides. The equation is that is equal to, that is a linear differential equations. And here, according to the working rule, we need to identify what is a p and q. Here p is nothing but 2x by 1 plus x square and q is equal to 4x square by 1 plus x square. Therefore, as per the linear differential equation, the integrating factor is e power of integration p dx. Therefore, integrating p dx is nothing but 2x by 1 plus x square. Now here we need to do that integrating. While we are going to take that 1 plus x square is equal to t, the numerator is a dt. The dt by t is nothing but integration of e power of the dt by t. The integration of dt by t is nothing but, that is log t. Therefore, the t is nothing but whatever we assume that 1 plus x square. And again, e power of log of 1 plus x square is nothing but the value is 1 plus x square. Because of according to the base is totally cancelled. The remaining term is 1 plus x square. Here, hence the general solution is y into integrating factor is equal to integration q into integrating factor dx. And here y is y as it is. Integrating factor is 1 by 1 plus x square and is equal to q of x. Integration of q of x is nothing but, here q of x is the 4x square by 1 plus x square. The integrating factor is 1 plus x square. Here 1 plus x square, 1 plus x square both are cancelled. The integration of 4x square into dx is nothing but 4 into x cube by 3 plus c is the solution. That is the required solution of the given differential equations. Next one, dy by dx plus 2y is equal to e power x plus x. And here also clearly the function is which is involving, that is a linear differential equations directly given the problem, where because of p comma q is a function of x, therefore p is equal to 2 and q is equal to e power x into plus x. And integrating factor is here also same, e power of integration, the 2 into dx. The integration of e power 2x means e power of 2x dx, 2x only. And the solution is y into, that means y into the integrating factor, that is e power of 2x is equal to integration of q, that is e power f plus x into the integrating factor is e power 2x into dx. And here e power of 3x plus into dx plus integration of e power 2x into x dx. And here e power of 3x by 3 plus e power of 2x is nothing but e power 2x into x minus 1 by the 2 and by 2 square plus c. That is integrating formula. We can find the solutions. This is the clear differential equation, that is a linear equation. We need to find the solution. And again, after the simplification of this one, we get the proper solution. This is the given problem. It is clearly we need to obtain properly. The next one, show that the orthogonal trajectory of a system of confocal and coaxial parabolas are self-orthogonal. Here the problem is based upon the self-orthogonal. Self-orthogonal means, as we know that after that formation of differential equation, we need to replace orthogonal. We get the same, the given differential equations here. But we need to understand what is a given equation. Here directly it is not given the equation. Based upon the system of confocal and coaxial parabolas are is nothing but y square is equal to 4 into x plus a. That is a equation of the system of confocal and coaxial equations. Here 4 y square is equal to 4 into x plus a. And here a is given the condition is the constants. We need to eliminate the arbitrary constants. That is only one arbitrary constants by applying the first order differential equations. Therefore, after applying the derivative with respect to x, that is 2y into dy by dx is equal to 4a, and a is equal to, by solving that, y by 2 into dy by dx. From the equation 1, we need to replace in the given equations, that is y square is equal to 4 into, that a is equal to, as we know that 4a is equal to, a is equal to 1 by 2 into dx, and x plus, that a is also y by 2 into dy by dx. And after that, similarly, the simplification, we obtain this, the given differential equation is over. That means elimination of arbitrary constants is over. And further, we need to replace the orthogonal trajectory. That is nothing but we replace dy by dx is equal to minus dx by dy. And here, from the second equations, here, after dy by dx is equal to, and here by simplification totally, that after the simplification, we obtain this third equation and second equation, both are the same equation. That is the meaning of here conclusion here. The given formation of differential equation and again the orthogonal trajectory, the both equations are same. That is the meaning of second and third equations are same. The equation is said to be orthogonal, self-orthogonal. Yeah, next one. The temperature of a cup of coffee is 90 degrees. while we are going to observe clearly it is not a differential equation like that. Based upon this one, the problem is under the applications of the differential equation, that is nothing but Newton's law of cooling. That is based upon that we need to understand. Therefore, according to the differential equations, let us assume that theta is the temperature of the body at time and theta naught is the temperature of the surrounding medium. And conclusion, the Newton's law of cooling, the formula theta by dt is equal to minus k into theta minus theta naught, and here minus k into theta minus theta naught, as given that theta naught is equal, that is the temperature of the surrounding body is the temperature is 24, that is the 20 naught is nothing but 24 degrees. And here our target is, here after the simplification, that is a dt by dt is equal to theta are one side and k into theta is other side, and again by applying the integrating on both sides, log of theta minus 24 degrees is equal to minus kt, it is a minus kt plus c is the value. And now here theta minus 24 degrees is equal to c into e power of minus kt. This is the important to remember our to finding the calculating the values, and based upon this here we need to find out what is the first kc and kt, and finally we need to find the theta value. And here first of all, when theta is equal to 0, the theta is equal to 92 degrees, because of whenever it is initially the theta is equal to t is equal to 0, the theta is equal, that is 92 degrees. While we are going to replacing here t and also the theta, we need to find out what is the c value. And after that theta is equal to 1, because of here 1 minute is given, whenever it is given the 1 minute at the time of the theta is equal, that is 80 degrees, because of it is 1 minute it was a cooled at 80 degrees. And based upon the theta it is equal to 1 and theta is equal to 80, we obtain the value of k value. And again after that finally find that what is the temperature theta, and theta is equal to 65 degrees, and theta is equal to. Therefore, by using here c value, by using the k value, we need to find out what is the t value. Here it is by using the, if it is using the calculator either ln values, we get the solutions. Finally, based upon the Newton's law of cooling, we need to find out c value. First it is a k value and also the t value. Yeah. Find the orthogonal trajectory of this is the problem. And it is given that orthogonal trajectory is nothing but according to the working rule, we need to eliminate the arbitrary constants. But in this problem, the arbitrary constant is a, we need to eliminate one arbitrary. That means by applying on both sides, that is with respect to x, we obtain the value. That is a 2x plus 2 and 3 by x is equal, that is a 0. Therefore, directly we eliminated that constant value. Therefore, no need to any modifications. Here x minus dy into dx by dy is equal to 0. That is after replacing like dy by dx minus dx by dy. Then find the solutions. After separating the variables, it is a log y is equal to log x plus c, that is nothing but y is equal to x plus c is the solutions. Y, that is no problem, y is equal to x or y is equal to x plus c or y by x is equal to c by taking the logs. And here the problem is clearly, here also we need to assume that what is a m, what is the n value, and m is equal to x power 4 into e power x minus 2m into xy square, and here n is also 2mx square y, and we need to calculate whether it is exact or not. First of all, the exact, if it is dou m by dou y, the value is nothing but first term it is 0 and second term it is minus 4mxy, and dou n by dou x is nothing but 4mxy. But here, while we are going to observe here, the equation is a not exact. That means it is a not exact differential equations. If it is a not exact means we need to further proceeding the methods, either the found by inspection or homogeneous or something. But here the problem is not a found by inspection, and it is not a homogeneous because of this condition is not suitable. Next, it is a not third method, and either it may be the fourth method or fifth method. By way of observing here, the problem is clearly in the form of 1 by n, because of n is a small quantity. That is simple rough terminology. 1 by n into dou m by dou y minus dou n by dou x. Therefore, n is nothing but the function is 2mx square y, and dou m by dou y is after previous completed, that is dou m by dou and dou m by x. The output it is clearly minus 4 by x, which is the meaning of function alone, that is x. That is f of x is a function alone. Therefore, minus 4 by x is the function. The integrating factor is e power of integration f of x. That is nothing but e power of minus 4 by x, that is nothing but e power of 1 by x power 4 is integrating factor. This can be multiplied with the given equations by 1 by, sorry, it is 1 by 1 by x power 4. 1 by x power 4, it may be exact differential equations. And here, after that multiplication 1 by x power 4, the equation is like this. Therefore, the equation is reduced to exact differential equations. And if it is exact differential equations, we need to find out what is the general solutions based upon here. M we can replace directly in the given equations, and n which is not containing, because of n should be, it is a containing x, that is free from 0 is nothing but 0. And here x power 4 is cancelled, and e power x is integration is e power x minus 2m, that my square is a common, and x square by 2, the 2 is also cancelled. Then we get the solutions. It is a m integrating y constant m, sorry, it is x power 4 is nothing but by 2 is also x power 4, and it is 1 by x cube. 1 by x cube is nothing but it is a clear solutions. Next one, find the orthogonal trajectory of the form causing through the origin. First we need to understand this is the equation of the center on the x-axis, and again here the equation we need to understand. Here also g is one constants. We need to eliminate the g by applying with respect to x only. That is a 2x plus conditions, and here also here 2g's we obtain. That value can replace in the equation 1. Therefore, the equation is like this. And here, after getting this one, it is no need to solve that, because of the function is like orthogonal trajectory, that is a dy by dx minus dx by dy. And now we need to solve the equations. Here, the problem is after separating that one by one, it is division by with conditions. Dividing with y square only. It is found by inspection, it is suitable. Or in other case, that is a function is exact, it is not exact, it is suitable for the homogeneous also. One mx plus n is also possibilities. Yeah, it is a final solution, or it may be by using the, which is the required solutions. Yeah, finally under the today class, that is a 10th problem. It is also based upon Newton's law of cooling. Clearly, we need to assume that based upon the initial step, that is a theta naught is 20 degrees because of the function. But here the main important is based upon this equation 1. And here also we need to find out what is the c, k, and t. Finally, what is the theta value? Same in the 6th or 5th problem, we need to same by using this one. First, what is the initial condition? That is 100 degrees, and at t is equal to, that is after 10 minutes, and again what is the 75 degrees. Based upon the c, find out what is the k, find out. And next one is a temperature. It may be after half an hour, that is meaning of 30 minutes. What is the value of t value? By using the c, k, and also t values, we need to find out what is the theta value. Yeah, these are the methods to find out according to like part A under the model 1. Okay, I hope everybody understood this is the model 1 part A. Anyhow, we are going to discuss that any method or any problems. First of all, we need to understand the formulas only. Without remembering the formulas, we are unable to survive, or we are unable to do that any problem. I hope everybody understood. Okay, we need to meet in the next class. That is a model 1, that is a part 2, that is question bank solutions.
Like, share and subscribe. Hit the bell icon for more updates.